I'll get started. If you have any questions regarding net neutrality and any other stuff, we'll discuss that offline. But for now, I'll just get started and we'll dig into it. Okay. So first and foremost, I think my previous speaker was referring to this fact, which is DevOps a reality today? For us, as Flipkart, as an org, DevOps is not just a reality, it's fundamentally core and essential to our existence. And I'll discuss why. Okay? But the title of my talk is Agility, the Holy Grail. I'll explain why that is. Okay? So first, like all engineers let's discuss semantics. Because we always love correcting people about semantics and establishing semantics. So let me establish that before I start into it. Okay? So first, again, as others have referred to it, is nobody is in agreement, complete agreement of what DevOps really is. Right? We generally know vaguely that DevOps means it's a tight coupling of development, operations, and QA. So ultimately, from our view, DevOps really is about, it's part of the agility story. And let me again ground truth what agility means to us, right? Agility is again a loaded word. It could mean agile practices or what, so on and so forth. So agility to us means ability to change in three constraints. One is ability to change fast, ability to change effectively, and ability to change efficiently. Okay? So given that that is the definition of agility that we are looking for, how does DevOps fit into that picture? Okay? Again, as far as DevOps is concerned, we don't really have a manifesto like an agile manifesto, so it's up to individual orgs implementation or individual orgs realization of what really DevOps is for them, right? One of the primary battles you'll see and has been referred to earlier is in the DevOps story is the battle between control and autonomy. Okay, and that will play a major role in my presentation and in our day-to-day work as well. Again, if you see DevOps, what DevOps mean to an enterprise and what DevOps mean to a startup, and their implementations of it look totally different. For a startup, DevOps could just mean a developer who is just doing deployment on his own and who is doing testing on its own, right? It could mean something totally different for an enterprise, right? And again, as I said, DevOps is a fuzzy term, so I'll be going at this in an opinionated way. But again, the fundamental tenet is agility as I defined it, okay? And for us, DevOps is the recognition that there is indeed tight coupling between development, tech operations, and QA, okay? And where there is tight coupling, how do we make use of this tight coupling to achieve agility? Okay, so one of the fundamental ways in which we realize this agility on a daily basis at Flipkart is velocity of our releases. We are a company that is a set of, you could say, maybe 10 to 100 mini companies, right? Each particular team is daily working on building and releasing their own services on a daily basis, and in case of our website, for example, we do multiple releases per day, right? So velocity of release is culturally or integrally at a very high pace for us, right? So it's about, release in the sense that you have 3-month release cycles where you are planning out features, okay, where there is a test suite that people can test it against for functional and acceptance testing, and you can certify a release, is simply not viable for us. For us, release means I need to implement this feature and try it out, and push it as soon, out of the door as soon as possible. If a PM thinks of it today, it could be out tomorrow morning in the first release, right? So that's the pace of releases we are talking about. And when you are talking about this pace of releases, something like a software moratorium, it's saying that let's keep our site stable, let's not release for a couple of days, it is blasphemous in our company. So I'll give you an example. The only time we ever say there is a moratorium is when something like the Big Billion Day or Diwali sale happens every year. And usually people say do a moratorium, but that never really happens. 8 a.m. when event starts at 8:30, deployments will be going on at 8 a.m. too, right? So software moratorium culturally is not a thing that we follow. So the common techniques that are there in place to make sure that this velocity of releases happen. One thing is A/B testing. If you are unsure about a feature, just put it behind an A/B testing flag and just let it go. Okay, let the people decide and whether that's a feature good for production push or not. Okay, and feature flags. That is, make a feature live. If you see that there are issues cropping up, just turn that feature off immediately. So one of the integral things we have is something called a config service, which is a global config management for everything. So essentially, turning off an entire feature or turning off an entire path for a user is essentially switching on that flag on and off. Okay, and canary deployments, which is just deploy on a set of servers. If you have a 100-node cluster, maybe a 200-node cluster, maybe deploy on 10 nodes. See how it's working out. If it's not working out, just kill it. Again, things get more complicated when we are talking about feature releases that involve state. That is, essentially, if something is modifying your DBs, or essentially if something is modifying your jobs or queues, you should be thinking about what my earlier data was looking like, what my data now is looking like. How do I reconcile this, or how do I enable both of them happening and allow for rollbacks? Right. So velocity of releases fundamentally needs to take care of all these things. So then we come to one of the important aspects of, the release cycle or dev cycle or everything as a whole, but more around the philosophy of DevOps as a whole, right? Fundamentally, what we are talking about is, actually, it shows only autonomy and automation, right? There is a third A, autonomy, automation, and abstraction, okay? Agility for any org requires these things, okay? What is autonomy mean, okay? I'm sure everybody knows what autonomy means, but autonomy in this context is that, in a very simple terms, if a developer wants to do something, okay, can he just go ahead and do it without an async process being involved? What is an async process? An async process is, if a developer wants to develop and deploy something, does he need to contact his manager for an approval, for resources, for servers? Does he need to contact ops for them to provision him with servers? Okay. Does he need to contact the QA team for them to set up a test rig and a continuous deployment pipeline? Okay. All these things are essentially hindering what a developer can do and the pace at which he can do it with. Okay. So fundamentally, autonomy is something that is necessary but not sufficient. Necessary for agility, right? In our case, we achieve autonomy by making certain things. One thing is, we have a very clear ownership split, right? Fundamentally, if you're an application developer, usually our developers are application developers. If you are an application developer, you are end-to-end responsible, okay? You are responsible for developing, you are responsible for deploying, you are responsible for operating your own services, and you are responsible for the sanity of testing and unit testing or whatever it is, right? There is no split between, there is a developer and there is a tester, okay? The developer is the tester, okay? And the ownership split, currently the way we have it is, the app teams are, say, I'm developing a new feature, I'm developing a new service, I need a cluster of maybe 100 servers. And it's TechOps just sets up the servers and gives it to them. And essentially, maintaining those servers is a developer's job. Log rotation or log pumping to batch systems or any real-time systems is developer responsibility. What infra team does from this point on is essentially, is a system up or down, okay? Is this guy screwing up other people's systems or networks, okay? Is essentially what they do. But this too, okay, is not at the level at which we want it, right? Still in this process, if you look at it, the TechOps is responsible for setting up the machines and giving it to you, okay? The way we are moving towards is essentially internal cloud-like thing, where you just say you want to do a deployment, you check in code and you say, I need this configuration, need to be deployed in this configuration, and machines get allocated to you, and you are deployed and you are good to go. You are good for production. Okay. So towards that, we are developing things like infrastructure as a service, bit distribution APIs for carrying data around wherever you want it across DCs within DC, and platforms as a service. An example was the config service that I showed before. Okay. By the way, I was saying automation. So all of these require automation, obviously, because what you really want to do is, it's not that a developer should be aware of every aspect of provisioning a system, operationalizing a system, and maintaining a system. It is that a developer needs to be aware of whatever he needs to be aware of, and the rest of it should be abstracted away in a repeatable, automatable fashion, where from the time you think about something to from the time where you deliver it is really minimized. And there is no friction, like someone said. It is frictionless operation. For source control. So our story around source control is pretty much, we do a trunk-based development. And it is a very open sourcey in a kind of way where if you go to enterprise companies, usually teams' source code are siloed to the teams. Okay? For us, there is no, it is a siloless org. Every team source code is open. You can just, every source repo is just a Git clone away. You go to a team and ask them what is the repo and clone it. If you want to change something, change it. But the team that is responsible for the code has the ownership to see whether I will accept this change into my main trunk line or not. If you want to fork it, just fork it and do your own service, right? But essentially, contributions is not limited to the team. Contributions can come from anywhere in the org. Okay? The processes we have in place to ensure the sanity is the strong ownership model of the team decides what goes into their trunk. Okay? And the team follows the process around pull requests. Okay? We expect if you are doing a commit, you do basic documentation of what that is supposed to do. You do basic unit testing, sanity testing, whatever it is. And again, you go through the basic code review procedures. Continuous integration and benchmark. So, continuous integration and benchmarking, here it says functional and regression testing, right? Suppose you are manufacturing a nail, not a mail. You are manufacturing a nail. You can do regression testing or functional testing on it two ways, right? You can say, is the circumference of it right? Is the length of it right? Is the conical shape at the end, is it right or not? The other way you can go about it is you can hit it with a hammer and see if it's working or not, right? So our approach to regression testing has to be hit it with a hammer and see if it's working or not. The reason we have to do this, especially for the UI facing things, is usually when we are talking about regressions, right? Regression is you expect things to be in this shape, but somehow they are not in that shape. When your expectation of the shape that things should be in this shape is changing so fast, that is, on day one your website looks like this, on day two your website is supposed to look like this, you don't even have time to set up your regression rigs, okay, to continuously do the testing. So our approach to functional and regression testing at a UI or user-facing level has to be, to some extent, maybe 70% of it we can automate it, but 30% of it is fundamentally non-automatable. Okay, it's changing daily, and something that's changing daily is not a good candidate for automation, right? And as far as functional and regression tests goes at a developer level, at a service level, it is fundamentally, again, unit tests and integration tests that a developer is supposed to write, and he is to ensure that they're passing. So our testing team is really someone who does manual testing for the 30% part of it, and helps developers in setting up their own test pipelines. Okay, they are not really owning. Essentially, in typical organizations, you see the development team owning the development and release process, and the testing team owning the QA and testing process. Here, the development team itself owns everything. The testing team is just there to enable them, right? For example, the parameters that we check for that are changing is, one is functionally, is it working or not? Is it working performantly or not? So it is just about hit the particular service that you have deployed with a load and see whether the load characteristics or the performance characteristics have changed from the last time, or have they drastically changed from what their intentions are, right? The way we do this is pretty much, some load testing tools like JMeter or WRK or Siege, and we do production log replays to have a higher degree of fidelity to actual traffic. But still, this doesn't really give us the picture when we are doing major deployments and where we are doing major overhauls, right? When you are testing, when you are doing perf testing, you are essentially testing a single service, maybe, and essentially that single service hitting whatever DB or service backend it has. It is not replicating the environment of maybe a million or 2 million users hitting you at 8:30 p.m. on Big Billion Day, right? That is a different kind of a scenario where essentially all your downstream systems are loaded to, you are loaded to, your upstream systems are loaded to, and your sibling systems are loaded. So load across the entire system is fundamentally different than performance testing on a single server. For things like that, we simulate massive number of users on external cloud environments to get it done. Another fundamental thing is all these processes are fine, but these processes have to be in coupling with architecture. When we are talking about agility, when we are talking about achieving agility with DevOps, you cannot do that without touching your architecture and fundamentally taking an opinion on how it will behave in this environment, right? Again, for no matter how much you test your services, no matter how much you test your code, things are going to fail. And I would like to describe as Flipkart as, you can say it's a house of cards, okay? But it depends on how good your construction is to say how resilient that house of cards is. If your design is bad, that house of cards will fall when one of the cards will fall, right? So fundamentally, understanding that this is the scenario we are working at, it's a complex service graph that is built up, and where every service might be dependent on multiple other services, and failure in any one of them could bring the whole site down, or could cascade failures across layers, right? Another fundamental thing is just deploying on more machines does not mean scaling, okay? You can deploy 1,000 web servers, but at the back end, if the service that is serving you cannot fundamentally take that load, you cannot scale, right? So what are the techniques we use to contain these or to deal with this? So one thing is containing failures. I'll give you an example. In typical web companies in the Web 1.0 world, even in the Web 2.0, what would happen was you would have full production load, one of your services would flap, okay? As soon as your service flaps, your latency on your web servers go up, okay? As soon as latency per request goes up, what happens is all your web server threads are occupied because what used to take 100 milliseconds to serve, for a request to be served, is taking 1 second right now. And what happens when you are taking 1 second to serve a request? Number of concurrent users essentially is coming down drastically. So essentially your site has crashed. So what we have to ensure is that any failure is well contained. That is, if a failure happens, for example, if we have a recommendation service, right? If a recommendation service where it recommends on the product page saying ki you can buy these products too. If a recommendation service is failing or degrading, okay, there is no point for the product page to be down or your checkout to be down or your browse page to be down, right? Fundamentally, it is a want. Recommendation is a want, it's not a need. You can get by shopping on Flipkart without recommendation module itself. So what you can simply do is you can say, okay, this is failing, okay, just don't show that module there. Don't slow down your pages or don't slow down your flows, just don't show the pages there. If something else is failing, don't bring the site down, bring that particular flow down. Okay, so containing failures is very important. And fallback execution path. What happens if a service dies? Do I go to a service cache to get data from? And what happens if I'm a service that is providing important functionality to a lot of different services, but one of my consumers is misbehaving. He's taking way too much of my bandwidth, or he's taking way too much of my CPU. We just say, let's do request throttling and give SLAs around that. Things like if you are doing a checkout, and if the checkout service is down, should the checkout stop? So I think banking has a similar issue where if you are doing an ATM withdrawal and the connection is not there, should the withdrawal stop? Not really. You do an you do a withdrawal, at least you need data that you have this much amount of money in your account, but you don't need it to be immediately committed that you have drawn this amount. Maybe a minute or two's lag is okay. Similarly, you don't immediately need to deduct stock given that you have enough stock in your warehouse of that particular inventory. A minute or two is okay. If the service outage is there, you can just replay the transaction on your backend systems and make sure everything is all right. Okay, so the thing is, when we are talking about things like resiliency, when we are talking about things like request throttling, we have to do expectation management with our stakeholders. We have to say, this is our SLAs for you and this is our SLAs for you. And that's natural part of the process. Metrics and monitoring. When you are deploying something and you don't know what will explode, metrics and monitoring becomes really important, right? Because anything can explode at any time. So we need to have metrics and monitoring at different levels. So everything could be fine on your infra, everything could be fine on your access, but suddenly your business metrics are dropping. I mean, this happens regularly during bad deployments. Everything is working fine, health checks are working fine, functionality is working fine. QA testing has happened thoroughly. Then we deploy it and we find out that suddenly checkouts have dropped. And then we have to do a root cause on why checkouts have dropped. Some weird bug has been introduced that can only be caught in production. Okay, and that doesn't reflect in any of our metrics except for our business metric, which says fundamentally the business that you are doing today is decreased or is less than what you were doing yesterday or what you were doing a week ago or what you were doing a year ago, right? And you have application metrics saying are the number of transactions that I was expecting the number of transactions I'm getting or not. Are the services that I'm talking to, okay, healthy or not? What are their response times like? How is it affecting my response times? So on and so forth. Similarly, access metrics of users and infrastructure metrics to see whether someone else is stealing your CPU or not. And deployment again is a part of this process, where you are saying, I'm going to do multiple deployments per day. Deployment cannot be a painful process. Deployment cannot be one person sitting, because developers are doing the deployment. A developer should not be sitting 6 hours per day and saying, I've initiated a deployment on 100 servers, it is failing on 3 servers, it is failing on 2 servers or whatever it is. Deployment should be a very lightweight activity. It should be, fundamentally when we are talking about agility, you coding and you committing it and it getting deployed should be so natural to you that you don't really think or you don't really worry about, oh no, I'm doing a release now. Release is a cumbersome process or deployment is a cumbersome process. Culturally, that should not be the way the direction is oriented. It should be oriented towards, you have to ensure that whatever you are doing is right, but once you have ensured that, just let it go. It goes and it gets deployed. So for that kind of a thing, we again need to do these seamless deployments, we need things like situational awareness. We need to think, if you have 2,000 servers, right? Which of those servers have which version of the code? What stage is your deployment in? Have you deployed to a canary service and it is waiting to go ahead to your real server farm? Okay, and fundamentally, has deployment failed on a certain set of servers? Because it always happens. Deployment fails for some reason or the other because we are dealing with, right now we are dealing with mutable infra. One server is not exactly the same as the other server. So deployment fails, and what does deploying on a single server mean? Okay, when do you say deployment has succeeded? If you say, I want it to be deployed on 300 servers, and if it was deployed on 275 servers, is that a success or a failure, right? From a user point of view, that could be a success because 275 servers are serving me. I'm not seeing any latency because 25 services are not there, right? So fundamentally, that is a success, even though some of the deployment on some of the nodes fail. So your deployment infra is supposed to take care of all of this and is supposed to enable all of this in a very lightweight manner. So again, summary of the whole thing. For us, DevOps again means it is just one aspect where you are saying development and operations and QA is very tightly linked together. Fundamentally, when things are tightly linked together, you have a huge efficiency advantage, huge speed advantage when they are done in sync. The thing where I talked about things being done in sync and async. When you cross organizational boundaries, things tend to be done async. Okay. When you say IT is responsible for this, development is responsible for this, things get done through things like tickets, emails, conversations. When you say this is tightly linked, you are responsible from end to end, it is you are thinking it and you are doing it. There is no lag of communication, there is no lag of request and response, right? Automation and abstractions, again, fundamentally there are many things that are automatable. Automation with the wrong abstraction doesn't add any value to you, okay? So if you give a developer access to Chef or Puppet and ask him to go ahead shape your infra as you want it, that doesn't really make any sense for a developer, because a developer from an ops point of view, Chef or Puppet is something that they could potentially deal with on a day-to-day basis. A developer doesn't really use Chef or Puppet on a day-to-day basis. So if the abstraction that you're exposing is Chef or Puppet or Ansible or whatever it is, right? Fundamentally, you will see attrition in the usage and you will see that being not used in the right way. What a developer really needs is, I need a set of machines, I need a deployment framework, I need a way to configure my infra at a high level of abstraction. So abstraction with automation with the right abstraction is the way to go. Again, agility cannot be an afterthought. As far as agility of operations goes, DevOps goes, it has to be designed from the ground up. It cannot be, I'll do this set in this silo, I'll do this thing in this silo, and somehow at a later date we'll integrate and agility will emerge. That will not happen. Agility is fundamentally, I think, someone was asking, in an org, how do you bring about DevOps or agility through DevOps? I think it starts with the culture, okay? Even though your, executives, see, I'm sure everybody knows the toughest part about implementing a project in an enterprise is actually bringing a change in the people, right? Implementing the systems is the easiest part. Bringing the change in the people and bringing the cultural shift in the people is the toughest part. And executive supporting it is a hit and miss, okay? An executive might be completely behind it, but if the foot soldier at the bottom layer is not believing in it, it just won't work, right? So culture is very important for you to achieve DevOps or agility through DevOps, okay? And again, agility, you have to optimize for the right things, because optimizing for the wrong things means you will go to failure very fast. So agility with the right things is what you have to do. I guess that's it. I think my presentation is over. I can take any questions you have. Yeah.
Mike, please. Questions.
Hi, myself Rishi from VMware.
Come again?
Rishi from VMware.
Yeah.
Yeah. So you talked about the containing failures, right? So where you said that if recommendation engine is not working properly, you'll just shut down that particular flow. So I wanted to understand how exactly you do it and how exactly you do it in an abstracted manner. That how exactly a developer can make that.
I'll tell you. So the way we do service resiliency is we use a third party. Netflix has a library called Hystrix, or we use similar techniques, which is what we say is fundamentally each service is put behind a barrier. Okay, we say each service that we are talking to receives certain set of my resources, which is each service. Essentially, when you are making a request to a service, it is a set of threads that are occupying that request. So you partition each service that you are talking to into its own dedicated thread pool.
It's like microservice kind of architecture.
So microservices again is a loaded word. Nobody is really sure what microservices is.
Right.
When does SOA become a microservice architecture is debatable.
Correct.
right? So I'll stay away from microservices and SOA, but essentially it's a service-oriented architecture. Our systems are all services and services talking to each other. From a resiliency point of view, what we say is each service is occupying a certain set of my resources. If that service is failing, okay, I'll have a barrier to say that failure is contained to this set of my resources. All my other resources that are talking to other services are working fine.
Okay.
The simplest form is if I have so many threads that I can concurrently operate, I'm only giving a thread pool of 10 to this particular service.
Okay.
And when I'm talking to that service, if that service ka latency has gone up or if it is failing, I'll just shut it down, shut down my thread pool or not send any requests across. Not sending any requests across means my latency has come back down to normal levels except whatever was failing manifests as failure in the website, only that part of it.
Can I ask one more question? So you, okay. So you talked.
Can you bring your mic up?
Yeah, you talked about thread pool, basically, I mean, bringing down that limit of the threads which you are providing
Sure.
to that particular service. So what kind of tool you use for that? I mean, is that inbuilt Flipkart?
No, so Histrix is a library we use, but we have something called a service proxy that I think Regu built. And what it does is essentially you can treat it as a proxy to talking to other services with all these niceties where you are saying ki, I can do resiliency, I can do distributed tracing and so on and so forth.
Okay, thanks. Thank you.
Thank you. You would like to thank Mr. Karthik. I would like to request Mr. Bala.
Sorry, I think there is another question there.
One more question. One last question before we thank him. Yes, sir.
Hello. First of all, Suman, thanks for this wonderful maturity that you've been taking it through. As you said, there are 2-3 areas where you're maturing. While you spoke about what is happening already, just wanted to understand where are we heading towards some of these silos that you see. One you see around tech ops data, abstraction. How does the developer really look at the data that is coming from it? And also, I didn't see any kind of the correlation, the Flume or the Splunk, how you can bring the business. So you saw the metrics separately as business versus application versus that. So where are we heading towards that in the journey? What is your next few steps is what I wanted to hear.
So I think we, at least us as an organization is heading towards, I think, autonomy much more, autonomy in a much more, you think of it, you get it kind of a way, okay? So there are organizations, there are companies, there are sectors where, again, it's about the battle of control versus autonomy, right? Where you would require control, where you would require things to be done in an ordered way, right? Examples could include financial and banking sectors. Compliance is a huge deal. Things have to be done in a particular way, in a narrow way, and they are there in place to do, I mean, to achieve certain things. But in many places, you know, we get caught up in this loop where things are done in a particular way because that's the way they have always been done. Not because that's the ideal way and that's the best way to do it. Okay? For us, it is about agility is the most important thing. Okay? Me releasing 5 features per day, okay, against someone who is doing a release every week, okay, I'm going to fundamentally kill that guy. Okay? There is not even a competition. So as a competitive advantage, agility is a requirement for us. Okay, and as far as where we are going, or I cannot speak of where the industry is going because I think it is so varied and, you know, as I said, varied and dispersed. But where we are going is go more towards autonomy, okay, go more towards enabling the developer, enabling folks to own things end to end rather than partitioning it into silos, okay. There is an enablement piece and there is a uniform piece where everyone is doing everything. I think that's the direction.
Yeah, thanks. I think we are out of time because otherwise I just
Sure,
wanted to...
we can take it off.
Yeah, we can take the questions offline because Suman is going to.
Sure.
With that, to present a memento to our speaker, requesting Mr. Bala Pedigari to kindly come on stage. Mr. Bala, yes, sir. With applause, let's thank our speaker, Mr.